Hi, welcome to our CompTIA Network Plus course. In this lesson, we will talk about transmission media and transceivers, and we will cover the following topics such as wireless, wired, transceivers, form factors, and connector types. So, transmission media and transceivers are fundamental elements of network communication systems. They serve as the physical pathways that enable data to flow seamlessly between network devices. Transmission media encompasses various physical mediums such as copper cables, fiber optic cables, and wireless signals, which provide the conduit for data transmission. Transceivers, on the other hand, are specialized electronic devices responsible for converting electrical signals into optical signals or vice versa, facilitating the transmission of data across diverse media types. These components play a very important role in ensuring efficient and reliable communication in modern networks, and they're responsible for bridging the gap between network devices and enabling data to be exchanged at high speeds with minimal errors. First topic is about wireless transmission media. Wireless transmission media are technologies that enable data transmission without physical connections such as cables. They operate by transmitting data through the air using electromagnetic waves. And this allows for flexible and mobile communication, making them essential in today's connected world. Wireless media provides various advantages, including mobility, which means devices can communicate without being tethered to fixed location. It provides flexibility, where networks can be easily expanded and reconfigured without complex cabling. Cost effectiveness, where wireless media can be more cost effective for certain applications, especially in scenarios where cabling is impractical or expensive. Examples of wireless transmission media includes Wi-Fi. We have cellular networks like GSM, LTE, 5G, satellite communication, and Bluetooth. So the first topic about wireless transmission medium is about 802.11 standards. 802.11 standards are a set of specifications developed by the Institute of Electrical and Electronic Engineers, or IEEE, that define the protocols for wireless local area networks, commonly known as Wi-Fi. These standards govern various aspects of wireless communication, including data transmission rates, frequency bands, modulation techniques. You have security protocols and network access methods. They play a very important role in ensuring compatibility and interoperability between different Wi-Fi devices and networks, allowing seamless communication regardless of the manufacturer or device type. The primary function of 802.11 standard is to establish a common framework for wireless communication, ensuring that different devices can communicate effectively and efficiently. They define the technical specifications and protocols that govern how data is transmitted and received over a wireless network. This standardization enables devices from various manufacturers to interact with each other, creating a unified and reliable wireless ecosystem. The standards also provide a roadmap for advancing Wi-Fi technology, with new versions introduced periodically to enhance speed, range, and security. The need for 802.11 standards arises from the complexities of wireless communication and the diverse range of devices and networks in use. Now, without standardization, wireless communication could be fragmented, with devices from different manufacturers unable to communicate effectively. And these standards act as a unifying force, ensuring interoperability and seamless integration of Wi-Fi devices into a network, regardless of manufacturer or device type. They also facilitate innovation by providing a framework for developing new technologies and features that improve Wi-Fi performance and capabilities. Several widely used 802.11 standards exist, each offering different capabilities and performance characteristics. Some common examples include 802.11a, you have B, you have G, N, you have AC, and you have AX. And these standards have evolved over time, providing significant improvements in data transmission rates, coverage, and security. Each standard typically builds upon the previous ones, incorporating new technologies and features to enhance performance and user experience. The latest standard is 802.11ax, or what we call as the Wi-Fi 6, right? Which offers significant improvements in speed, efficiency, and capacity, enabling faster and more reliable wireless connectivity in dense environment. Now let's talk about cellular networks. So cellular networks are mobile communication systems that provide wireless connectivity over large areas. They utilize a cellular architecture, dividing a geographical region into smaller cells, each with a base station or cell tower. And these towers transmit and receive radio signals to and from mobile devices within their coverage areas. Cellular networks enable mobile devices such as smartphones, tablets, and laptops to communicate and access data services across wide geographical regions. They facilitate voice calls, text messages, internet browsing, and various other mobile applications. Data is transmitted over the network through radio waves, with a signal being passed between different cell towers as a mobile device moves across the coverage area. Now, cellular networks are essential for providing mobile connectivity in our increasingly mobile-centric world. They enable people to stay connected, to communicate, and access information anytime and anywhere. This has revolutionized communication, transportation, commerce, and many other aspects of modern life. Examples of cellular network technologies include 3G, 4G, and 5G, and each generation offering improved speed and capabilities. These technologies represent advancements in mobile communication, enabling faster data speeds, lower latency, and enhanced network capacity. For example, 5G networks are designed to support a wide range of applications, including high-definition video streaming. So another type of wireless communication is satellite communication. Satellite comms leverages artificial satellites orbiting Earth to relay signals over vast distances. This technology enables long-range wireless communication, bridging gaps in terrestrial networks and providing connectivity to even the most remote regions. Its significance lies in facilitating global communication and enabling various critical applications. So, satellites act as relay stations, receiving signals from ground stations or user devices, and amplifying them and retransmitting them to other ground stations or users. This process allows for communication across continents, oceans, and even in the challenging terrains where traditional infrastructure is limited. Now, one of the most prominent applications of satellite communication is satellite internet services. These services utilize satellites to provide internet access to areas lacking terrestrial infrastructure, making it possible to connect people and businesses in remote locations. Another important application is GPS, or Global Positioning System, which relies on a network of satellites to pinpoint location data. GPS is essential for navigation, mapping, and various other applications. Let's talk about the second topic, which is wired transmission media. Wired transmission media are physical cables that transmit data in networks. This media utilize physical connections to facilitate data transmission, offering high-speed and reliable communications. Wired media are essential for applications that demand high-speed, reliable, and secure data transmission. So here are the different types of wire transmission media. So we have coaxial cable, we also have twisted pair cables, and we have fiber optic cables. We're going to talk about those in detail on the next few slides. So the 802.3 family of standards developed by IEEE governs the specifications for wired local area networks. These standards are essential for ensuring interoperability and compatibility among various devices and components within a wired network infrastructure. 802.3 standards are designed to streamline communication within wired networks, ensuring seamless data exchange between connected devices, and they define the crucial aspects such as the physical layer characteristics. Single mode versus the multi-mode fiber. What is a single mode fiber? Single mode fibers are designed for long distance communication. It utilizes a small core diameter and a single path for light transmission, minimizing signal loss over extensive distances. This results in significantly higher bandwidth capabilities and faster data transfer speeds. Single-mode fibers is ideal for telecommunication networks and backbone infrastructure where long-range connectivity is essential. Now, what are multi-mode fibers? Multi-mode fibers, on the other hand, is engineered for shorter distances. It has a larger core diameter, allowing multiple light paths to travel simultaneously, and this makes it suitable for local area networks and data centers, where distances are relatively short. While multimode fibers offer lower bandwidth compared to single mode, it is typically more cost-effective for short-range applications. Now, what are the key differences? So, of course, the primary distinction lies in the core diameter and the way light propagates. Single-mode fiber uses a smaller core, restricting light to a single path, while multimode fibers feature a larger core allowing multiple light paths. This difference in the core size and light propagation influences their bandwidth capacity and distance limitations. In terms of applications, as I've said, the single-mode fiber finds its primary use in long-haul telecommunications, backbone networks, and high-speed data transmission applications. Multimode fiber, being more economical and suitable for shorter distances, is commonly deployed in LANs, data centers, and enterprise networks. There's another wire transmission media here, which is called DAC, or direct attached copper cable. So DAC cables are a specialized type of copper-based cable designed for high-speed data transmission over short distances. They're commonly used in data center and network room environments where cost-effectiveness and high performance are important for interconnecting devices. DAC cables offer several advantages over traditional copper cables, particularly in data center applications. They're typically more cost-effective due to the use of simpler and less complex components, and their compact size and lower power consumption also contribute to their efficiency in tight spaces within the data centers. DAC cables are designed for direct connection between devices, eliminating the need for intermediate network equipment like switches or routers. This direct connection provides a low latency path for data transmission, ensuring high performance for demanding applications such as high-speed networking and storage area networks. Next one are coaxial cables. So coaxial cables are often referred to as coax. It's a type of electrical cable that consists of a central conductor, as you will see here, surrounded by an insulating layer, a braided metallic shielded, and an outer jacket here. This construction enables coaxial cable to carry high-frequency signals with minimal signal loss, making it suitable for various applications like cable TV and broadband internet. The central conductor, typically made of copper, transmits the signal, while the surrounding shield protects the signal from interference and noise. Coaxial cable finds its niche in scenarios where high bandwidth transmission over moderate distances is required. The cable's design effectively mitigates signal degradation caused by electromagnetic interference or EMI and radio frequency interference or RFI, ensuring reliable signal delivery. Then the braided shield acts as a Faraday cage, this one, which effectively blocks external electromagnetic fields from impacting the signal within the cable. Now let's talk about the cable speeds for Ethernet cables. So the speed of cables refers to the maximum transfer rate that it can support. Different cable types have different speed capabilities. For Cat5e cables are the most common types of cable used for Ethernet networks. They can support data transfer rates up to 1G over a distance of up to 100 meters. Here. Now, Cat6 cables are newer types of cable that can support data transfer rates up to 1 Gbps, but they can also support up to 10 Gbps over a distance of up to 55 meters. They can support 1 GB over a distance of 100 meters. Then you have Cat6a, which are designed to support 10 Gbps data transfer rates over a distance of 100 meters. And the Cat7 cables, which is the latest generation of Ethernet cable, can support data transfer rates of up to 10 Gbps. If you're running on 100 meters, but it can shoot up to 100 Gbps up to 15 meters. So the maximum length for each cable type refers to the maximum distance that data can reliably transmitted over the cable. The maximum length may vary depending on the specific cable and the environment in which it is installed. Let's talk about plenum cable. Plenum cables features a fire-resistant jacket designed to minimize toxic fume generation in air spaces. Within buildings, these spaces often house critical infrastructure like wiring and ventilation systems. This special jacket helps limit the spread of fire and harmful smoke, enhancing safety during emergencies. This one is the plenum cable. Now, the non-plenum cable, in contrast, utilizes a standard plastic jacket suitable for areas with less stringent fire safety requirements. While it may not offer the same fire retardant properties as plenum cable, it's often more cost-effective options for installations where fire risk is lower, like residential settings or non-critical commercial spaces. So the selection of between plenum and non-plenum cable hinges on safety and regulatory compliance. Building codes and fire safety standards often dictate the use of plenum cable in certain areas, ensuring the safety of occupants and minimizing potential fire hazards. And failure to adhere to these regulations can result in penalties and compromise safety. Now let's talk about transceivers. So transceivers play a very important role in modern network communications, acting as a bridge between different types of network media and devices. They facilitate seamless data transmission by converting electrical signals to optical signals and vice versa. So you got to think of them as the interpreters in networking and enabling devices to understand and communicate with each other despite using different languages. These versatile devices are essential for creating a robust and reliable network infrastructure. Now, to illustrate, imagine a computer, right, that is connected to a network switch. So let's say this is the switch, PC, using a copper cable. So this cable carries electrical signals, right? However, the network switch might connect to a server using fiber optic cable. So this cable uses light pulses for data transmission. Here, this is where the transceivers will step in. So the transceiver on the computer network interface card, right, converts the electrical signals to optical signals, allowing them to travel through the fiber optic cable to the network switch. Okay. Now, so these devices, right, are responsible for converting between electrical and optical signals to ensure that you gotta have a smooth data flow across different types of media. So transceivers will enable seamless communication between devices utilizing copper cabling and fiber optic cabling, bridging the gap between different network technologies. So they also ensure compatibility between devices from various manufacturers, allowing them to interact effectively within the network. Ethernet protocol. So Ethernet, right, is a widely used network protocol that serves as the foundation for LANs, or local area networks. It defines the rules and standards for data transmission across wired and wireless networks within a limited geographical area, such as an office building or a home. So how does it work? So the Ethernet protocol governs how data is packaged and transmitted between devices on the network. It ensures standardized communication, allowing different devices from different manufacturers to communicate directly with each other. So why is it important? The standardization provided by the Ethernet protocol is relevant or essential for interoperability between devices on a LAN. It ensures that data packets are formatted and transmitted in a consistent way, allowing different types of computers, servers, and network devices to communicate effectively. So examples of Ethernet standards like gigabit, which is capable of speeds up to 1 Gbps, 10 Gbps, which supports or up to 10 Gbps. So these standards cater to different network needs and demands. Let's talk about fiber channel protocol. So fiber channel is a high-speed networking protocol primarily used for SANs or storage area networks. It was designed to overcome the limitations of traditional network protocols such as Ethernet when it comes to high bandwidth, low latency data transfer, which is important for demanding storage applications. Fiber channel operates at the physical and data link layer of the OSI model, providing a dedicated high-speed connection between storage devices and servers. It uses fiber optic cables to transmit data at speeds from 1 to 32 Gbps, with even higher speeds being explored. So one of the key advantages of fiber channel is its low latency, and this means that data can be transferred quickly and efficiently, making it ideal for applications like database transactions, video editing, and high-performance computing. Its ability to handle large volumes of data simultaneously make it a preferred choice for data centers and enterprise environments. Fiber channel is renowned for its reliability and scalability. Its robust detection and correction mechanism ensure data integrity, while it supports for multiple devices and connections, allows for flexible and scalable storage infrastructure. Another noteworthy feature of fiber channel is its support for what we call a zoning. So which allows network administrators to control which devices can communicate with each other. And this enhances security and improves network performance by preventing unnecessary traffic. Let's talk about transceiver form factors. So we have the SFPs, or small form factor pluggable. So SFP is a compact, hot pluggable transceiver that is used to connect network devices. It offers flexibility and scalability in networking. These transceivers are typically used in gigabit or 1G to 10G Ethernet applications, and they're commonly found in switches, routers, and other network devices. So examples include SFP, SFP Plus, and SFP28, for example. The next one is quad small form factor pluggable, QSFP. It is a high-density transceiver designed for high-speed networks. It provides high bandwidth and density that is important for modern data centers. So QSFP transceivers are typically used for 40G, right? Gbps up to 100G applications. They're commonly found in high-performance switches, routers, and servers. So if you know Cisco CCIE, so these are data center switches. So from the spine to the leaf, they use 40G up to 100G links. Okay. Connector types. So connectors are essential components in various applications, connecting cables to devices and ensuring seamless data transmission and signal flow. They provide a physical interface between the cable and the device, facilitating transfer of data, power, and other signals. Connectors come in various forms and sizes, each designed for specific applications and cable types. So the first type is the SC, or the subscriber connector. SC is a widely recognized and widely used fiber optic connector type, particularly prevalent in subscriber networks. It boasts a robust design that ensures reliable, secure connections crucial for delivering stable and consistent data transmission. SC connectors find their primary application in subscriber networks. So SC, or subscriber connectors, are designed to withstand environmental factors such as temperature fluctuations, humidity, and dust, making them suitable for diverse deployment environments. So in terms of versatility, SC connectors are adaptable and can be used in various applications, including networking, telecommunications, and data centers, showcasing their versatility. Okay. Another one is LC, local connector. So LC connectors are renowned for their compact size. They're actually very small, smaller than the SC, making them ideal choice for scenarios where space is a constraint. Their smaller footprint enables high density configurations, allowing for a greater number of connections within a limited area. These are particular advantages in data centers and other environments where space optimization is crucial. In terms of the latching mechanism, LC connectors incorporate a secure latching mechanism here, ensuring reliable and stable connections. And this mechanism provides a secure lock, preventing accidental disconnections and ensuring data integrity. The latching design also adds to the overall durability of the connector, enhancing its reliability in demanding environments. Another one is ST, the straight tip. ST connectors are popular choice for fiber optic connections due to their simple design and reliable performance as well. They are characterized by a straightforward push-pull mechanism for connecting and disconnecting fiber optic cables. The ST connector's design involves a precise alignment of the connector tip and the mating socket, ensuring a secure and reliable connection. This precise alignment minimizes the signal loss and ensures optimal data transmission. The ST connector's robust construction makes it suitable for various demanding environments, including telecoms, DCs, or data center networks, and industrial systems. MPO, multi-fiber push-on. So MPO is a type of fiber optic connector that allows for high-density connections. It features a single connector that accommodates multiple fiber strands, typically 8, 12, and 24 fibers in a single housing. So MPO connectors are designed with a push-on mechanism for fast and efficient deployment, and this eliminates the need for individual fiber connectors, streamlining installation and reducing the deployment time. This one is a familiar connector, the RJ11 registered jack. So of course, these are primarily used in telephone system, the analog phones in your house. It uses RJ11. They have a simple 2-wire configuration designed for voice transmission. And despite their simplicity, RJ11 connectors have been widely adopted as a standard connection type for telephone lines, ensuring compatibility with various devices. So this standardization has made it easy to connect phones, fax machines, and other devices to the telephone network. Another familiar connector is the RJ45. Of course, this is the standard connector for connecting devices on an Ethernet network. They are found on computers, routers, switches, NICs, and other network devices. And these connectors are designed to transmit data at various speeds, including 1G and 10G Ethernet. So the RJ45 connectors have unique 8-pin configuration, which enables the transmission of data signals. And these pins arranged in a specific order, allowing for both data transmission and power supply. Now the F-type, of course, also familiar with this one. The F-type connector is a common type of connector used for coax, right? Coaxial cables. It is a threaded connector that provides a secure and reliable connection. F-type connectors are typically used for transmitting radio frequency signals, such as those used in cable television, satellite TV, and the radio antenna connections. So the F-type connectors are designed specifically for coaxial cables, which are used for transmitting RF signals. So in terms of connector selection consideration, so choosing the right connector is very important for establishing a reliable and efficient network connection. The selection process involves considering several factors, ensuring compatibility between the cable type and the intended application. The data rate required for the network, right? Let me put it here. Data rate is a primary consideration, right? High-speed networks demand connectors capable of handling the increased data flow, while lower speed networks may utilize simpler and less expensive connectors. Environmental conditions as well play an important role in connector selection. Like, for example, connection exposed to harsh environments might necessitate robust connectors designed for dust, moisture, or extreme temperatures. Conversely, indoor applications with controlled environments may allow for less rugged connectors. Now, the type of cable used for the network connection is another key factor. Type. Fiber optic cables, known for their high bandwidth and long distance capabilities, often utilize like SCLC and ST, right? However, the copper cables used in traditional Ethernet networks commonly employ RJ45 connectors. And lastly, consider the specific requirements of the network application. Like, for example, a data center might demand high-density connectors like MPO, which can support multiple fiber connections in a compact space. So understanding the application's needs and ensures a suitable and efficient connector choice is very important in the connector selection process. Okay? All right, that's the end of the lesson. Here we spoke about wireless transmission media, wire transition media, the transceivers, the form factors, and the connector types. Okay? Thank you very much for watching the video.